Welcome to today's lecture. We are starting the chemistry syllabus, Jamb 2026 syllabus. Remember that this lecture is tailored from Jamb syllabus, so we are destroying the syllabus. So this is the first lecture, and do well to get your pen and your book, your chemistry book, to jot down anything you pick from this lecture, because you are definitely going to need it for your subsequent revision. Our topic that we are starting with, if you look at the syllabus, you are going to figure that the first topic there that Jamb recommends or suggests you get accustomed to is elements, compound, and mixture. And let's go, tag along, and let's destroy this. So elements, compounds, and mixture. What is element? Chemistry textbook made us understand that element is a pure substance made of one type of atom. So there's only one type of atom in this substance. That's why it's called an element. Okay. Some textbook will also tell you that element is a substance that cannot be split, okay, by an ordinary physical process. So that's what some textbook will define an element to be. But the simplest way to define element is a pure substance made of one type of atom, and these are elements. This one is oxygen element, though this one here, this particular one here, is oxygen molecule. Okay, molecule. This is oxygen molecule, O2 oxygen molecule. Then O, when it's only O, is oxygen atom. Okay, oxygen atom. This one is iron atom. Okay, that's that for that. Let's look at compound. Compound is a substance formed when two or more elements chemically combine together in fixed proportion. Okay, when two or more elements are chemically combined together in fixed proportion. Remember the law of definite proportion. Okay, all pure sample of a particular chemical compound contains similar elements of the same proportion by mass. So the same proportion of elements by mass in a compound. So a compound is two or more elements chemically combined together with a fixed proportion. So that's that. So compounds like we have water, we have sodium chloride. Here in water we have hydrogen and oxygen with the ratio of 2 molecules of hydrogen and 1 molecule of oxygen. So here we have water with the ratio of 2 atoms of hydrogen and 1 atom of oxygen. And here we have sodium chloride, and we have 1 atom of sodium and 1 atom of chlorine. That's it. That's the ratio. So let's now look at mixture. Mixture is a physical combination of 2 or more substances. Mixture is physical. It's not chemical. Mixture is physical. A physical combination of 2 or more substances, not chemically bonded, and can be separated by physical means. So you use physical means to separate mixture. Their physical combination is a physical combination of 2 or more substances, not chemically bonded, not chemically combined together. When they become chemically combined together, they are called compounds. Okay. So example of mixture includes air. You know, air is a mixture of different gases, different particles, and so on and so forth. You have salt solution. So salt solution is also a mixture because you can recover the salt through physical process. It's not a chemical. There was no reaction that occur. If you carry sodium chloride and pour it inside water, it's not a chemical reaction. It's a mixture, a mixture of salt and water, because that salt, you can recover it. You can recover it through crystallization. Okay. You boil it, you heat it to dryness, and it crystallizes. It crystallizes out, okay, because it's a soluble salt. So the method of recovering an insoluble salt is precipitation, while the method of recovering a soluble salt from a solution is crystallization, because it's soluble. So salts are defined based on their solubility. We are going to get to that topic. It's a very interesting topic, and I will talk more on salts. So let's look at chemical and physical changes. Chemical and physical changes. The first we have here is chemical changes. Chemical changes are irreversible. That's the first feature. Number 2, new substance is formed. Okay, new substance formed. For example, rusting of iron. Okay, rusting of metal. Iron is very common. So let's say rusting of iron. That is a chemical change. Burning. That's a chemical change. A new substance is formed and is irreversible. Okay, though there are some chemical changes that is reversible, like reversible reaction. Okay, but for the reversible reaction to occur, you have to enable some kind of environment for the reversible reaction to occur. There are stuff that are needed. That's something that you need to do for the reversible reaction to occur. So it doesn't just occur spontaneously. Even though the reversible reaction wants to occur, it has to occur at a certain condition. A certain condition has to be met for the reversible to occur. But for physical change, the reaction, the physical change is reversible. Okay, if you mix substances together, substances that are not chemically combined together, you can reverse it. You can separate them. Okay, no new substance formed. No new substance is formed. The same way you mixed those substances is the same way you are going to recover them. No new substance is going to be formed. Nothing changes. For example, melting ice. If you melt ice, you are still going to get water. Nothing changes. You turn water to ice, just that is in a solid state. If the temperature increases, it returns back to water. So that's a physical change. Okay, it's not chemically combined. It's just that the hydrogen bond, okay, between the molecules of the water is now stronger and closer. That's why you now have ice. Okay, immediately the temperature rises to the extent that the hydrogen bond is broken, hydrogen bond is a weak intermolecular force. So when the hydrogen bond is broken, you get your water back. So it's a physical process. So dissolving sugar, you dissolve sugar inside water, no new substance is formed. Okay, so that's a physical process. You can as well recover that sugar from water by heating and crystallization. That's it. Now let's look at pure and impure substances. Jamb said all these that we are treating, we should know how to differentiate them. And we should know how to recognize them. When we see them or when they are being talked about, we should be able to recognize them. We should be able to pick them. So we are looking at pure and impure substances. Under pure substance, the definition is a substance that have definite composition and sharp boiling/melting point. A pure substance has a definite composition. It is composed of sodium and chlorine. That's a pure substance. It is composed of carbon and oxygen. That's a pure substance. And it also has a sharp boiling and melting point. It does not have a high melting point or high boiling point. No, it's minimal. Okay, that's a pure substance. Then impure substance contains other substances. A pure substance is pure on its own. Maybe for example, carbon is a pure substance. When it now contains other substance like oxygen, it becomes impure. Iron is a pure substance. When it now reacts or it now contains other substances like oxygen, it becomes impure. Okay, that's why in the extraction of metal or in extraction of elements, you call those additions, those substances added to them that normally react with them in their pure state, you call them impurities. Okay, that's why they are called impure substance. It's like a substance that something is added to it, additive, something is added to it. And usually impure substances shows range of boiling points / melting points. They usually have high melting and boiling points because of the impurities you have in those impure substances. So let's now quickly look at it. Pure substance is a pure substance gotten without no additive. Nothing is added. If you are getting pure iron, you are getting pure iron, only iron, nothing added. It has definite composition, iron. If you are getting pure copper, you are getting pure copper, no oxygen, no other additive, no other particle, nothing added. And it usually has a sharp melting and boiling point. The melting and boiling point is fixed. It's not varying. Okay, it's not varying. Okay, but impure substances, it contains other substances in it. Okay, and I give you an example. I say, for example, iron having carbon in it, or iron having oxygen in it. That's those additives are impurity. Okay, they are no longer pure. When you say you are pure, it shows that nothing is added to you, nothing has been placed on you. You are still pure. So that's that. And it has a range of boiling points. You go bring this one, it will get higher boiling points and melting points. You will bring this one, your own go there a little bit higher. You will bring varying boiling and melting points, usually higher boiling points than the pure forms. Okay, so let's look at purity test. How is purity test carried out? How do you find out if a substance is pure or impure? Number one, sharpness of melting and boiling points is used as a criterion. Okay, so how long does it take to boil? How long does it take to melt? That's what you use as a criterion. I always tell you that when impurity are present in a substance, you usually take higher temperature to melt and boil, other than when the substance is pure. So this is the criterion used. Now let's look at boiling, density, freezing, and melting point. We have to understand this concept. Jamb said we must understand these concepts as stated in the syllabus. So let's look at boiling point first. We already discussed this in physics. If you have taken my physics lecture, this is going to be like bread and akara. This is going to be like moi moi to you. This is going to be like turkey, as if you are just enjoying. Okay, so let's look at boiling point. Boiling point can be defined as the temperature at which the liquid changes to gas. Okay, at which the liquid changes to gas. That's that point or the temperature, the measurement of that temperature at which the liquid turns to gas. That's what boiling point. Okay, and this happens when the saturated vapor pressure in the liquid equals the external pressure, or the environmental pressure is equal. So liquid turn towards gas. That's what boiling point. Let's look at freezing point. Freezing point is the temperature at which liquid changes to what? Solid. That temperature at which liquid changes to solid. That's what freezing point. Melting point is what? Melting point is the temperature at which solid changes to liquid. Melting. That temperature at which solid changes to liquid. And melting usually occurs when the pressure of the system is greater than the pressure of the atmosphere. Okay, the molecular pressure in the solid is now higher. When you increase the molecular pressure of the solid, that's when melting occur. Okay, the molecular pressure at that given time or at that given temperature is enough to increase the collision of the molecules of the solid to start melting. So when it melts, because of too much movement of the molecules, too much collision of the molecules, the solid begins to thin out, okay, and turn to liquid. So density. Now we have to define density. We already did this in physics, and this is just going to be like akara to you if you've taken my physics lecture. So density is the mass per unit volume. This thing that's like P here, fine P, is density. It symbolizes density. It's the mass of a substance per unit volume, where M over V. Volume is the unit volume. That's V is volume. M is mass. If you are told to solve density, all you need to do is to substitute mass into the formula, substitute volume into the formula, and you divide and get your density. Note, these properties are used to identify and test purity of substances. Freezing point to boiling point to melting point to density. 4 of these are used to test what? The purity of a substance. So Jamb can ask you which of these is not used to test the purity of substances. Okay, you are going to see boiling point, you are going to see freezing point, you are going to see melting point, you are going to see density, and they will now bring another thing that is not here. You already know the answer. Now let's look at separation processes / technique. Many textbooks will say separation technique. Let's look at separation technique. Okay, the first we have here is evaporation. And what is evaporation? Evaporation removes solvent, leaves solute. So you use evaporation to separate solvent from solute. Okay, and you do that in salt. When you want to separate salt from water, you use evaporation. Okay, and it all depends. You might have to boil for it to evaporate. Okay, you need to increase the energy in the system so that molecules can escape. Okay, so that the solvent can escape, so that the solute will now remain in the system. Solvent will escape, solute will remain in the system. Okay, solvent is giving off. The solute remains in the system. Hope you know the meaning of solute and the meaning of solvent. A solvent is that which dissolves a solute. A solute is that which is dissolved in a solvent, or a solute is that dissolved by a solvent. Okay, so that's that for that. And there are 2 types of solvent. You have the polar and non-polar solvent. Okay, the polar solvent is the solvent like water. That's the polar solvent. Widely, it dissolves inorganic compounds. Inorganic compounds, polar solvents. But non-polar solvents usually dissolve organic compounds. Okay, yes, organic compounds. Polar solvent is like water. Non-polar solvent is like petrol, diesel, kerosene, and so on and so forth. So let's look at simple distillation. That's distillation. What's distillation? It's the method used to separate liquid from solution based on boiling point differences. Okay, you separate liquid from a solution. You have different liquids in a solution with different boiling points. So you use this method of distillation, simple distillation, to separate them, separate the liquid from the solution because of the boiling point of the liquid. You use it to separate it from the solution, because when you get to that boiling point, the liquid will escape and you trap it. It depends if you need the liquid or you don't need it. If you don't need it, you allow it to escape into the atmosphere. But if you need it, you trap it with a column and utilize it for whatever you want to use it for. Now let's look at fractional distillation. They are related but different concepts. Okay, fractional distillation is a method employed to separate mixture of liquid with close boiling points. So this one, the distillation own, is used to separate a liquid, okay, from a solution. One liquid, you want to separate it from a solution because of its what? Varying boiling points, okay, because of the boiling point differences of the 2 liquids, okay. But here you have liquids, more than 2 liquids, with close boiling points. For example, the fractional distillation of crude oil. You distillate it into fraction. Okay, you need a fractionating column for fractional distillation. It is done in a fractionating column. This substance will be trapped here in the column. This one will be trapped here in the column. This one with this boiling point trapped here in the column. This one with this boiling point trapped here in the column, and so on and so forth. So you need a fractionating column for fractional distillation. So let's look at sublimation. What is sublimation? Sublimation is a separating technique whereby substances sublime. Sublimation means when a substance sublime, it means that this substance turns from solid straight to gas. Okay, it turns from what? Solid to gas. It does not pass through liquid. You know that if you carry ice block, come now, for example, ice block is water. It's made of water, for example. When you melt ice block, you are going to get water. That's it turned from solid to liquid. So if you want to get gas, that's steam, you have to boil it so that gas can or steam can evaporate, okay, off the solution. But for sublimation, the substance turns from that solid straight to gas. And substances that exhibit sublimation is iodine. I know that iodine is used to demonstrate the diffusion, okay, diffusion, the way iodine diffuses from a region of a higher concentration to gas, a region of a lower concentration, okay. So iodine is a perfect example of a substance that's sublime. And also camphor, camphor. Let's look at recrystallization. Recrystallization. What is recrystallization? It purifies solid by dissolving and crystallizing it. You dissolve a solid and you recrystallize it out. When you dissolve the solid, the impurities during the crystallization process, the impurities are separated, and you recover the pure form, and the impurities are separated. Recrystallization, recrystallization. But only crystallization means recovering a solid, a soluble solid from a solution. Only crystallization. It means recovering a soluble solid from a solution. That's why it's used to recover soluble salts. But recrystallization is the process whereby solids are purified by dissolving and crystallizing them out. So it's just like repeating a process. You dissolve it and you crystallize it out. So now let's look at chromatography. We have different types of chromatography. Here, they just listed paper and Coulomb because that was the ones listed by Jamb, okay? We have about 4 or 5 types of chromatography. We have paper chromatography, we have Coulomb chromatography, we have gas chromatography, and so on and so forth. So chromatography is the separation of a mixture based on solubility and absorption. Based on the solubility and absorption of the mixture, that's where we use chromatography. You are separating this mixture based on the solubility and absorption, okay? So such as pigments in ink. You use it for pigments in ink. That's why when you put, for example, you put a paper here and you drop ink on the paper, for example. If the ink is soluble and it easily gets absorbed, you can easily separate the other component of the ink. The other component of the ink is separated. You see other components of the ink falling off from below that paper. Or there's a specialized paper used for paper chromatography. So let's look at fractional crystallization. It separates solutes with different solubilities. When there are different solubilities, this one is highly soluble, this one is semi-soluble, this one is sparingly soluble, and so on and so forth. So the solutes with different solubility, that's when you use fractional crystallization. And it's done in a fractionating column, okay? In a fractionating column, in fractions, okay? So we have magnetization. Magnetization is used to remove magnetic material, such as iron fillings from sand and so on and so forth. So you use magnets to remove magnetic material, okay? That's also a separation technique. So we have decantation, which is separating liquid from sediment by pouring it off. It's just like you go carry erosion water, gully erosion water. You take it home and you store it at home. When you store it at home, after some time, maybe after like 2-3 hours, you come back, the water must have sedimented. All the particles in that erosion water must have sedimented. So if you want to decant, what decant means is that you pour off that upper layer of the water that is clearer, and you are going to have the sediments of the particles below. So you just decant and you have the sediments below. So this decantation is also used. People that used to do akamu. If you used to do akamu, pap and apu, fufu, it's also used a method to separate the water from the sediment. That sediment is the apu, that sediment is the akamu, that sediment is the fufu, and you have to separate the water and so on and so forth. So filtration, let's look at the filtration process. Filtration is the method of separating insoluble solid from a solution. You use it to separate insoluble solid from a solution. When the solid is soluble, you can't filtrate. If the solid is soluble, you can't filtrate, and it is used for solids, non-liquid. Insoluble solid from a solution, okay? Or insoluble solid from a liquid. And how do you do that? You can use a filter paper to separate insoluble solid from a liquid. You use filter paper, commonly used. The next we have here is centrifugation. And what is centrifugation? Using centrifugal force, like I explained in physics. What is centrifugal force? Centrifugal force is the force that attracts particles from the center. It pulls all the particles from the center. It puts the particle away from the center. Okay, so maybe this is a cup now, for example, and there are particles inside. It pulls all the particles away from the center. So you have the particles the side beside the cups inside at the sides. Okay, it is done with a what? A centrifuge. There's a particular device called a centrifuge. Okay, you use it to generate this centrifugal force to separate these particles from this liquid, and it's used to separate plasma from blood. You know that your blood is a mixture. Okay, there is plasma in the blood, there is white blood cell in the blood, there is red blood cell in the blood, there is a platelet, and there's also serum. So you use centrifugal force or a centrifuge to separate, okay, particles, okay, from a liquid or from a solution. Now that we have understood elements, compounds, and mixture and various separation techniques in chemistry, let's now test the knowledge we've acquired so far by answering some Jamb must repeat questions. Jamb must repeat questions. Question 81. Which of the following is a mixture? A. Sodium chloride. B. Oxygen gas. C. Air. D. Water. What's the answer? Drop the answer in the comment section. Question 82. Which of the following is a physical change? A. Rusting of iron. B. Burning of wood. C. Dissolving of sugar in water. D. Cooking rice. What's the answer? Drop the answer in the comment section. Question 84. A pure substance is best identified by A. Its color. B. Its sharp melting or boiling point. C. Its taste. D. Its density alone. What's the answer? Drop the answer in the comment section. Question 85. Which method is most suitable for separating a mixture of ethanol and water? A. Filtration. B. Fractional distillation. C. Sublimation. D. Magnetization. What's the answer? Drop the answer in the comment section. Question 86. Paper chromatography is commonly used to what? A. Separate salt from water. B. Separate pigments in ink. C. Separate iron fillings from sand. D. Separate oil from water. What's the answer? Drop the answer in the comment section. So if you encountered problem answering these simple questions, let me teach you that Jamb is overrated. You can access this material. As you can see, the material contains all the topics in the Jamb syllabus, tailored from the Jamb syllabus. Very short and concise, straight to the point, okay? You don't go waste your time at all. So you can get this file with just 1K. Send me a DM number in my bio.